Let me tell you about something that will fundamentally alter your understanding of existence. For decades, parallel universes were the stuff of science fiction, imaginative, speculation, philosophical thought experiments, entertaining stories about alternate realities where you made different choices and lived different lives. That's changing, and the evidence is more compelling than you might ever have imagined. Recent discoveries in physics, cosmology, and quantum mechanics have converged on a stunning conclusion. Parallel universes aren't just possible, they're probable. And according to our best theories of how reality works, they may be inevitable. The mathematics that describes our universe, the equations that have been tested and verified to extraordinary precision, those same equations seem to demand the existence of other worlds. You exist in infinite worlds. Right now, as you're reading this, there are other versions of you, countless other versions, perhaps infinitely many, living different lives, making different choices, experiencing different realities. Some of those versions are almost identical to you, differing only in some trivial detail, some quantum fluctuation that went one way instead of another. Others are radically different versions of you that made different decisions at crucial moments and ended up in completely different circumstances. This isn't metaphor. This isn't poetry. This is what the physics is telling us. Reality isn't real, not in the singular sense we've always assumed. Reality is plural. Reality is infinite. And we're just one slice of an incomprehensibly vast multiverse. Let me take you through the evidence, because I want you to understand that this isn't speculation. This is where the science points. Let me start with quantum mechanics, because this is where the case for parallel universes becomes most compelling. Quantum mechanics is the most successful theory in the history of science. Its predictions have been verified to more decimal places than any other theory. It describes the behavior of atoms, molecules, electrons, photons, everything that makes up the physical world. Without quantum mechanics, we couldn't have computers, lasers, MRI machines, or most of modern technology. But quantum mechanics is also deeply strange. It describes a world that violates our everyday intuitions in almost every way. One of the strangest features is superposition. Before a quantum system is measured, it doesn't have definite properties. It exists in a combination of all possible states simultaneously. An electron doesn't have a definite position until you measure it. Before measurement, it's in a superposition of being in many places at once. When you do measure it, the superposition collapses, the electron suddenly acquires a definite position. But which position? Quantum mechanics only gives probabilities. There's a 30% chance it's here, a 50% chance it's there, a 20% chance it's somewhere else. The outcome is fundamentally random. This randomness troubled many of the founders of quantum mechanics, including Einstein, who famously said, "God does not play dice." But experiment after experiment has confirmed that quantum randomness is real. The universe really is probabilistic at its deepest level. Or is it? In 1957, a young physicist named Hugh Everett proposed a radical alternative. What if the wave function doesn't collapse? What if all the possible outcomes actually happen, but in different branches of reality? This is the many worlds interpretation of quantum mechanics. According to Everett, when you measure an electron's position, you don't get one random outcome while the others disappear. You get all outcomes, but in different branches of a rapidly multiplying universe. In one branch, you see the electron here. In another branch, you see it there. In a third branch, you see it somewhere else. All branches are equally real. This sounds extravagant, creating entire universes every time a quantum measurement occurs. But here's the remarkable thing. Many worlds is actually the simplest interpretation of quantum mechanics. It takes the equation seriously and doesn't add anything. The standard interpretation requires an extra postulate, the collapse of the wave function upon measurement. But no one has ever observed this collapse. No one has ever explained what triggers it. No one has ever described the mechanism by which it occurs. The collapse is added to the theory by hand, without any experimental justification. Many worlds simply drops this extra postulate. The wave function evolves according to the Schrödinger equation, which is deterministic and continuous. No collapse, no randomness at the fundamental level. The apparent randomness we observe is just because we're in one branch and can't see the others? Let me be more precise about what this means. Consider a simple quantum experiment, measuring the spin of an electron. Spin can be either up or down along any axis you choose to measure. Before measurement, the electron is in a superposition of both states. In the standard interpretation, measurement collapses the superposition, and you get one result randomly either up or down. In many worlds, measurement causes the universe to branch. In one branch, you see spin up. In the other branch, you see spin down. Both branches are real. Both versions of you exist. Before the measurement, there was one you. After the measurement, there are two yous, one in each branch, each remembering the past identically, but now diverging into different futures. This happens every time a quantum event occurs. Every radioactive decay, every photon absorption, every molecular collision, all of these are quantum events, and all of them cause branching. The number of branches multiplies exponentially, creating a vast tree of parallel realities, and quantum events happen constantly, trillions upon trillions of times per second, everywhere in the universe. The branching is relentless, continuous, incomprehensibly prolific. The number of parallel universes being created is beyond astronomical. This might sound wasteful, all these universes, just to explain quantum mechanics, but in physics, simplicity isn't about the number of entities, it's about the number of assumptions. Many worlds makes fewer assumptions than alternatives. It just takes the equations seriously. And here's what's remarkable. Many worlds is gaining acceptance among physicists. A survey at a quantum mechanics conference found that about 20% of physicists favor many worlds, making it one of the most popular interpretations. Among physicists who work on the foundations of quantum mechanics, the percentage is even higher. This isn't fringe science. This is mainstream physics. Now let me tell you about another path to parallel universes, one that comes from cosmology rather than quantum mechanics. Our universe began in an event called the Big Bang about 13.8 billion years ago. In the first fraction of a second, the universe underwent a period of incredibly rapid expansion called inflation. Space itself expanded faster than light, stretching a tiny patch of quantum fluctuations into the vast cosmos we see today. Inflation solves several puzzles about our universe, why it's so uniform, why it's so flat, why it has the particular structure we observe. It's been spectacularly confirmed by observations of the cosmic microwave background, the afterglow of the Big Bang. But inflation has a startling implication. It doesn't stop. The original proposal, called eternal inflation, suggests that inflation is not a one-time event, but an ongoing process. In most of space, inflation continues forever, constantly creating new regions of expanding space. Occasionally, a region will stop inflating and form a bubble universe, a cosmos like ours, with matter, energy, galaxies, and potentially life. Our universe is one such bubble. But there are infinitely many others, an endless froth of bubble universes, each one a complete cosmos in its own right. These bubbles are not all the same. The physical constants, the strength of gravity, the masses of particles, the nature of the forces can differ from bubble to bubble. Some bubbles might have physics so different that atoms couldn't form. Others might be remarkably similar to ours. And in an infinite multiverse, some bubbles would be virtually identical, containing copies of Earth, copies of you, copies of everything we know. This is called the level 2 multiverse in physicist Max Tegmark's classification scheme. It's not the parallel universes of quantum mechanics, it's a separate prediction arising from different physics. But both point to the same conclusion: our universe is not unique. Let me explain why eternal inflation seems to be an inevitable consequence of our best theories. Inflation is driven by a quantum field called the inflaton field. During inflation, this field has a lot of energy, and that energy drives the rapid expansion of space. Eventually, the field rolls down to a lower energy state, and inflation ends. That's when a bubble universe forms. But here's the key. Inflation happens faster than the inflaton field rolls down. Even as bubbles form, more space is being created between them. The inflationary regions expand faster than the bubbles can fill them. Inflation never ends. It just creates more and more space, with bubbles forming here and there in an endless sea of expansion. This isn't a speculative add-on to inflation theory. It's a straightforward consequence of the physics. If inflation happened once, and the evidence strongly suggests it did, then it's almost certainly still happening somewhere, creating new universes forever. The bubbles are separated by enormous distances far greater than we could ever hope to cross. We can never visit other bubble universes or communicate with them. They're causally disconnected from us, outside our cosmic horizon forever. But that doesn't mean they don't exist. The mathematics says they do. And the same mathematics that predicted the observable properties of our universe, properties we've verified with extraordinary precision, predicts the existence of this infinite multiverse. Now let me tell you about a third path to parallel universes, perhaps the most radical of all. I mentioned Max Tegmark earlier. He's proposed something called the mathematical universe hypothesis. According to this view, mathematical existence is the same as physical existence. Every mathematical structure exists physically somewhere in the ultimate multiverse. This sounds abstract, so let me make it concrete. Our universe is described by certain mathematical equations, the standard model of particle physics, general relativity, quantum mechanics. These equations constitute a mathematical structure. And our universe, according to Tegmark, is that mathematical structure. We don't just describe the universe with math, we are math. But there are infinitely many mathematical structures, infinitely many consistent sets of equations, infinitely many possible laws of physics. If our universe is a mathematical structure, why should it be the only one that exists? Why should this particular set of equations be privileged? Tegmark's answer: it isn't. All mathematical structures exist. All possible laws of physics are realized somewhere. The multiverse contains not just parallel universes with the same physics as ours, but universes with completely different physics, different numbers of dimensions, different forces, different fundamental particles, different everything. This is the level 4 multiverse, the ultimate ensemble of all possible realities. It's the most expansive version of the multiverse hypothesis, and it's the logical endpoint of taking the connection between mathematics and physics seriously. Now, you might think this is too speculative, that we've left science behind and entered pure philosophy, but there's a reason physicists take this idea seriously. The equations of physics are unreasonably effective, as Eugene Wigner observed. They describe nature with incredible precision, often in ways that weren't anticipated when the equations were first written down. This suggests that the equations aren't just useful descriptions, they're capturing something deep about the nature of reality. If math describes reality so perfectly, maybe it's because reality is mathematical. And if reality is mathematical, then the distinction between real and mathematical collapses. Mathematical structures don't describe universes. They are universes. And there are infinitely many of them. Let me now tell you about some recent developments that have strengthened the case for parallel universes. In 2015, researchers at Griffith University in Australia proposed an experimental test of many worlds. Their many interacting worlds theory suggests that parallel universes don't just passively coexist, they interact with each other. This interaction could, in principle, be detected. The idea is that quantum effects, the weird phenomena like superposition and entanglement, arise from the interaction of our world with nearby parallel worlds. If this is right, then by studying quantum behavior very carefully, we might find signatures of these interactions. The research is ongoing, and no definitive detection has been made. But the fact that testable predictions are being proposed shows that many worlds is not beyond the reach of science. It makes predictions. It can, in principle, be verified or falsified. Meanwhile, cosmologists continue to find support for eternal inflation. The patterns in the cosmic microwave background, the tiny temperature fluctuations left over from the Big Bang, are exactly what inflationary models predict. And those same models predict the eternal creation of bubble universes. In 2013, the Planck satellite provided the most precise measurements yet of the cosmic microwave background. The data matched inflationary predictions beautifully. While we can't directly observe other bubble universes, the theory that predicts them has passed every test we've thrown at it. There's also theoretical work on the multiverse measure problem, the challenge of making predictions in a multiverse where infinitely many outcomes occur. This is a hard problem, but physicists are making progress. The fact that serious effort is going into solving this problem shows that the multiverse is taken seriously as a scientific hypothesis. And then there are the fine-tuning arguments. The fundamental constants of physics, the masses of particles, the strengths of forces, the cosmological constant, appear to be fine-tuned for the existence of life. If they were slightly different, stars couldn't form, chemistry couldn't happen, and life would be impossible. Why are the constants fine-tuned? One explanation is that there are many universes with different constants, and we obviously find ourselves in one where life is possible. This is the anthropic explanation, and it requires a multiverse. The multiverse isn't invoked arbitrarily, it's predicted by our best theories, and it explains an otherwise puzzling feature of our universe. That's how science works. You follow the evidence where it leads. In part 2, I want to explore what it actually means to exist in infinite worlds. What are these other versions of you like? How do they differ? Can we ever know anything about them? And what does it mean for our sense of self, our choices, our very identity, if there are infinitely many copies of us living infinitely many different lives? Because the physics isn't just abstract equations. It has implications, profound implications for how we should understand ourselves and our place in existence. So we've established that parallel universes aren't science fiction. They're the straightforward implication of our best physical theories. Quantum mechanics, in its many worlds interpretation, tells us that the universe branches constantly, creating new realities with every quantum event. Cosmology, through eternal inflation, tells us that our universe is just one bubble in an infinite froth of bubble universes. And the mathematical universe hypothesis suggests that every possible mathematical structure, every possible set of physical laws exists as a real universe somewhere in the ultimate multiverse. You exist in infinite worlds. But what does that actually mean? What are these other worlds like? What are the other versions of you doing right now? And how should we think about ourselves when there are infinitely many copies of us living infinitely many different lives? Let me explore this in detail because the implications are both fascinating and disturbing. Let's start with the quantum multiverse, the parallel universes created by the many worlds interpretation of quantum mechanics. Every time a quantum event occurs, the universe branches. In one branch, the event has one outcome. In another branch, it has a different outcome. Both branches are equally real. Now, most quantum events don't matter much at the macroscopic level. Whether a particular electron spins up or down in some distant star doesn't affect your life in any noticeable way. Most branches are almost identical to each other, differing only in microscopic details. But sometimes quantum events have macroscopic consequences. And this is where things get interesting. Consider radioactive decay. An atomic nucleus has a certain probability of decaying at any given moment. In one branch, it decays. In another, it doesn't. Usually, this doesn't matter. One atom among trillions makes no difference. But sometimes it does matter. The famous thought experiment of Schrödinger's cat illustrates this. A cat is placed in a box with a radioactive atom. If the atom decays, it triggers a mechanism that kills the cat. If it doesn't decay, the cat lives. Before you open the box, quantum mechanics says the atom is in a superposition of decayed and not decayed. And because the cat's fate depends on the atom, the cat is in a superposition too, both alive and dead at the same time. In the many worlds interpretation, both outcomes happen. In one branch, the atom decays and the cat dies. In another branch, the atom doesn't decay and the cat lives. When you open the box, you don't cause one outcome to happen. You become entangled with the system and you split two. In one branch, you see a dead cat. In another branch, you see a living cat. Both versions of you exist. This is disturbing enough when we're talking about cats. But let's make it personal. Imagine you're making a decision, say, whether to take a new job. At some level, your decision-making process involves quantum events in your brain. Neurons firing, neurotransmitters being released, ions flowing through channels, all of these involve quantum processes. In one branch, the quantum fluctuations tip your decision one way and you take the job. In another branch, they tip it the other way and you don't. Both branches are real. Both versions of you exist. In one branch, you move to a new city, start a new life, meet new people, have new experiences. In another branch, you stay where you are and your life unfolds differently. Both lives are really lived. And this isn't just one decision. Every decision you make, every moment of every day, involves quantum processes that could go different ways. The branching is constant, continuous, exponential. The number of versions of you multiplies without limit. Right now, there are versions of you who made different choices at every fork in the road. Versions who chose different careers, different partners, different cities. Versions who took risks you didn't take, avoided mistakes you made, succeeded where you failed, and failed where you succeeded. Some of these versions are living lives that seem better than yours. They got the job, won the lottery, avoided the accident, found happiness in ways you didn't. Other versions are living lives that seem worse. They made terrible decisions, suffered misfortunes, ended up in circumstances you're glad you escaped. All of these versions are real. All of them are you, or rather all of them emerged from the same source you emerged from and have an equal claim to being you. This raises profound questions about identity. What does it mean to be you when there are infinitely many versions of you? Which one is the real you? The answer, of course, is that they're all real. The concept of a single, unified you persisting through time is an approximation, a useful fiction that breaks down when you consider the quantum nature of reality. Now let me talk about the cosmological multiverse, the bubble universe is created by eternal inflation. This is a different kind of parallel universe. The quantum multiverse consists of branches that diverge from a common origin and continue to share the same underlying physics. The bubble universes of eternal inflation are separate regions of space-time with potentially different physics. In the inflationary multiverse, the fundamental constants can vary from bubble to bubble. The strength of gravity, the mass of the electron, the value of the cosmological constant, all of these might be different in other bubbles. Most combinations of constants don't allow for anything interesting. In some bubbles, atoms can't form. In others, stars can't ignite. In others, the universe collapses before anything complex can emerge. These bubbles are sterile, empty, lifeless, devoid of structure. But in an infinite multiverse, even unlikely combinations occur infinitely many times. Some bubbles have constants similar to ours, similar enough to allow atoms, stars, planets, chemistry, and life. And in an infinite ensemble of such bubbles, some will be virtually identical to our universe. This is a remarkable implication. In an infinite multiverse, any configuration of matter that can exist does exist infinitely many times, including configurations like Earth with all its continents and oceans and cities, including configurations like you. In the inflationary multiverse, there are other versions of Earth, not quantum branches of our Earth, but independently formed copies created by the random fluctuations of inflation. These copies are identical to our Earth in every detail, including the presence of a person identical to you. How many such copies exist? If the multiverse is infinite, the answer is infinitely many. There are infinitely many Earths, infinitely many versions of you, scattered throughout the infinite expanse of the inflationary multiverse. These copies are far away, inconceivably far, beyond any possibility of contact or communication. But they exist. The mathematics of eternal inflation guarantees it. Let me try to give you a sense of the distances involved. In an infinite universe with uniform conditions, any particular arrangement of matter, like a human body or a planet or a galaxy, has a finite probability of occurring. In a large enough volume, any arrangement will occur just by chance. How large a volume do you need to find a copy of you? The calculations are mind-boggling. You'd need to search a sphere about 10, 10, 29 meters in radius. That's a 1 followed by 10, 29 zeros. This number is so large that writing it out in standard notation would require more atoms than exist in the observable universe. But in an infinite multiverse, such distances are trivial. There's plenty of room for infinitely many copies of everything. Now let me tell you about a different kind of parallel universe, the many worlds of the mathematical universe hypothesis. According to this view, every consistent mathematical structure corresponds to a real universe. Not just variations on our physics, but completely different physics, different forces, different particles, different dimensions, different rules entirely. Some of these mathematical structures would be simple universes with minimal content, minimal complexity, minimal interest. Others would be incredibly complex universes with rich structures, intricate patterns, perhaps forms of existence and experience we can't begin to imagine. In the level 4 multiverse, there's a universe for every possible set of physical laws. There are universes where gravity repels instead of attracts, universes with 4 spatial dimensions instead of 3. Universes where time runs differently, where causation works differently, where the very concepts of space and matter don't apply. Most of these universes would be uninhabitable, incompatible with anything like life as we know it. But in an infinite ensemble, some would support life, and some would support beings capable of wondering about the nature of reality, just as we do. What would such beings be like? We can't say. They would be as different from us as the mathematical structures underlying their universes are different from the structures underlying ours. They might have experiences and forms of consciousness utterly alien to anything we can conceive. And yet, according to the mathematical universe hypothesis, they would be just as real as we are. Mathematical existence is physical existence. Every consistent structure exists. This is the ultimate democracy of reality. Every possibility is realized. Every mathematical structure has its day. Nothing is merely possible. Everything possible is actual, somewhere in the infinite multiverse. Now let me address a question that I know you're asking. Can we ever know that these parallel universes exist? Can we test these ideas? Is this science or speculation? The honest answer is that we can't directly observe other universes. The quantum branches are decohered from us. Quantum mechanics prevents us from interfering with them. The bubble universes are beyond our cosmic horizon. No signal from them can ever reach us. The level 4 universes have different physics. There's no way to send information across mathematical structures. But that doesn't mean these ideas are untestable. Science doesn't always work by direct observation. Sometimes it works by inference, by prediction, by the explanatory power of theories. Consider electrons. No one has ever seen an electron. They're too small for any microscope. But we believe in electrons because theories involving electrons make accurate predictions. We infer the existence of electrons from their effects. The same logic applies to parallel universes. We can't see them directly, but the theories that predict them make testable predictions about things we can observe. The many worlds interpretation, for example, makes the same predictions as other interpretations of quantum mechanics for any experiment we can perform. It's not directly testable against alternatives, but it gains support from its simplicity, its elegance, and its ability to explain quantum phenomena without ad hoc postulates like wave function collapse. Eternal inflation makes predictions about the statistical properties of our universe, the patterns in the cosmic microwave background, the distribution of galaxies, the value of the cosmological constant. These predictions have been confirmed. The theory that makes these successful predictions also predicts other bubble universes. The mathematical universe hypothesis is more speculative, but it too has implications. If all mathematical structures exist, then we should expect to find ourselves in a structure that's relatively simple, one that requires less information to specify. Our universe does seem to be governed by elegant, relatively simple equations. This is what the hypothesis predicts. None of this is proof, but science never provides proof-only evidence, and the evidence is mounting that our universe is not alone. Let me now explore what these ideas mean for our understanding of probability and prediction. In a multiverse where everything happens, what does it mean to say something is likely or unlikely? If every outcome occurs in some branch or some bubble, then in what sense can we assign probabilities? This is called the measure problem, and it's one of the deepest challenges facing multiverse theories. Consider a simple example. You flip a coin. In some branches it comes up heads, and others tails. If all branches are equally real, what does it mean to say the coin has a 50% chance of landing heads? One answer is that probability refers to the weight or proportion of branches. If more branches have heads than tails, then heads is more likely. But counting branches is tricky. There are infinitely many, and different ways of counting give different answers. Another answer is that probability is about rational expectation. Before the coin flip, you don't know which branch you'll end up in. You should assign equal credence to heads and tails because you have no reason to favor one over the other. Probability is about your state of knowledge, not about the objective frequency of outcomes. These approaches can be made mathematically rigorous, and they give the right answers for standard quantum probabilities, but the interpretation remains contested. The measure problem hasn't been fully solved. This has implications beyond physics. If all possibilities are realized somewhere, then in what sense should we care about the future? If every possible outcome happens in some branch, then your choices don't determine what happens, they just determine which branch you're in. Some people find this troubling. It seems to undermine the significance of our choices. If I choose to do something noble, what does it matter if there are other branches where I choose to do something terrible? But I think this concern is misplaced. You don't experience other branches, you experience this one. Your choices determine your experience, even if other versions of you are having different experiences. The existence of other branches doesn't diminish the reality of your life any more than the existence of other people diminishes your life. In fact, the multiverse might make our choices more significant, not less. In a single universe, your choice is just one event among many. In a multiverse, your choice determines which infinite family of future branches you'll experience. The stakes are multiplied, not reduced. Now let me talk about what parallel universes mean for some of the biggest questions humans have ever asked. First, the question of uniqueness. Are we special? Is our universe special? Is Earth special? The multiverse answers with a resounding no. Our universe is one among infinitely many. Earth is one among infinitely many. You are one among infinitely many. There's nothing unique about us. Copies of us exist throughout the infinite expanse of reality. For some people, this is deeply troubling. It seems to eliminate our significance, our importance, our meaning. If we're just one among infinitely many, why do we matter? But I think this reaction is misguided. Uniqueness was never the source of our significance. What makes you significant is not that you're one of a kind, it's that you're a conscious being with experiences, relationships, and values. The existence of other versions of you doesn't change any of that. Think about it this way. If you discovered that you had an identical twin you'd never known about, would that make your life less meaningful? Of course not. The twin has their own experiences, their own relationships, their own significance, and so do you. You matter because of what you are, not because of how many copies of you exist. Second, the question of origins. Why does the universe exist? Why is there something rather than nothing? The multiverse suggests a remarkable answer. If all possible universes exist, if mathematical existence is physical existence, then there's no need to explain why the universe exists. Existence is the default. Non-existence is what would need explaining. This doesn't fully resolve the mystery. You can still ask why all possible universes exist, why mathematical structures are real, but the question shifts from why this universe to why existence at all. And the latter question might be easier to address or might be unanswerable in principle. Third, the question of fine-tuning. Why are the constants of physics suitable for life? The multiverse provides a natural explanation. If there are infinitely many universes with different constants, then some will be suitable for life by chance. We find ourselves in one of those because we couldn't exist in the others. This is the anthropic explanation. Some people dislike the anthropic explanation. They find it unsatisfying, a cop-out. But it's a perfectly legitimate scientific explanation. It's the same logic we use to explain why we find ourselves on a planet with water rather than on a barren asteroid. Not every place can support life, and we obviously find ourselves in one that can. The multiverse makes this logic cosmic. Not every universe can support life, and we obviously find ourselves in one that can. The fine-tuning isn't miraculous, it's selection bias. In part 3, I want to explore the deepest implications of parallel universes, what they mean for free will, for morality, for the meaning of life, and for how we should live knowing that we exist in infinite worlds. Because if the multiverse is real, it changes everything about how we should understand ourselves and our place in existence. So we've established that parallel universes are not science fiction, but the logical implication of our best physical theories. We've explored the quantum multiverse, where reality branches with every quantum event. We've explored the cosmological multiverse, where eternal inflation creates an infinite froth of bubble universes. We've explored the mathematical multiverse, where every consistent mathematical structure exists as a physical reality. You exist in infinite worlds. Infinite versions of you are living infinite variations of your life right now across the vast expanse of the multiverse. Now I want to confront the deepest implications of this discovery. What does it mean for free will, for morality, for the meaning of life, for how we should live, knowing that every possible version of our lives is being lived somewhere? These questions might seem philosophical rather than scientific, but they're not optional. If the multiverse is real and our best physics says it is, then we have to grapple with what it means. We can't just accept the equations and ignore the implications. Let me start with free will, because this is where the multiverse seems most threatening to our ordinary understanding of ourselves. We normally think of free will as the ability to choose between different possibilities. When you face a decision, you consider your options, weigh the pros and cons, and make a choice. The option you choose becomes real. The options you reject remain merely possible roads not taken. But in the multiverse, all options become real. When you face a decision, you don't choose one path and reject the others. You, or rather different versions of you, take all paths. Every option is realized in some branch. Does this mean you don't really have free will? If every choice is made somewhere, in what sense are you choosing? Let me work through this carefully, because I think the situation is more subtle than it first appears. First, note that even in a single universe, free will is puzzling. If the laws of physics are deterministic, then your choices are determined by prior causes, and free will is an illusion. If the laws are indeterministic, then your choices involve randomness, but random choices don't seem free either. They're just arbitrary. The multiverse doesn't create the problem of free will. It inherits it from the underlying physics. Whether you're in one universe or many, the same puzzles arise. Second, note that in the multiverse, your deliberation still matters. When you face a decision, you think about it, you consider reasons, you weigh evidence. This deliberation affects what you do in this branch. The fact that other versions of you make different choices doesn't change the fact that you make your choice. You're not somehow responsible for what other versions do. You're only responsible for your own actions in your own branch. Think of it this way. Suppose you have a twin who makes different choices than you. Your twin's choices don't undermine your free will. They're your twin's choices, not yours. The same logic applies to your quantum duplicates. They make their choices, you make yours. Third, and most importantly, consider what free will actually is. Philosophers who have thought carefully about this distinguish between different concepts of freedom. One concept is libertarian free will, the ability to have done otherwise in exactly the same circumstances. This concept is problematic even in a single universe, because it's not clear what it would mean for the laws of physics to allow multiple outcomes from identical conditions. Another concept is compatibilist free will, the ability to act on your own reasons without external coercion. On this view, you're free when your actions flow from your own deliberation, your own values, your own character. It doesn't matter whether the outcome was determined in advance. The multiverse is compatible with compatibilist free will. In each branch, you act on your own reasons. Your choices flow from your own deliberation. The fact that other versions of you make different choices doesn't change this. Each version acts on their own reasons in their own branch. I think compatibilism is the right way to think about free will, with or without the multiverse. What matters is not whether you could have done otherwise in some metaphysical sense, but whether you act on your own reasons without external compulsion. The multiverse doesn't threaten this. But I want to go further. I want to suggest that the multiverse might actually enhance our understanding of free will rather than undermining it. Consider, in the multiverse, every possible choice is made. This means that your choice, your specific choice in your specific branch, is not predetermined by anything outside you. The laws of physics don't uniquely determine what you'll do. They're consistent with all options. What makes the difference is you, your deliberation, your values, your character. In a single deterministic universe, you might worry that you're just a puppet of the initial conditions, that your choices were fixed at the Big Bang. But in the multiverse, the initial conditions don't uniquely determine your choice. All choices are consistent with the laws and the initial conditions. What makes the difference is you. This is a strange kind of freedom. Freedom to be the author of your choices, even though all choices are realized somewhere. But I think it captures something important about what free will means. You're not a puppet. You're an author. Your choices are genuinely yours. Now let me turn to morality. Because the multiverse raises profound questions about ethics. If every possible action is taken in some branch, does morality still matter? If there's a branch where you do the right thing and a branch where you do the wrong thing, what's the point of trying to be good? This is a serious question, and I want to take it seriously. First, let me note that moral nihilism, the view that nothing matters, doesn't follow from the multiverse. The fact that every action is taken somewhere doesn't mean that all actions are equally good. Some actions cause suffering, others cause flourishing. The suffering and flourishing are real in each branch where they occur. When you choose to help someone, you create real benefit in your branch. When you choose to harm someone, you create real harm in your branch. The existence of other branches doesn't change this. The consequences of your actions are real for you and for those affected by your choices. Second, consider what morality is actually about. Morality isn't about ensuring that only good outcomes exist in the universe. If that were the standard, no one could ever be moral. There's always some branch where things go badly. Morality is about your relationship to your actions, about whether you act with integrity, compassion, and wisdom. It's about the kind of person you are, the kind of life you live, the kind of relationships you build. These things are real in your branch, and they matter to you and to those around you. Third, consider the perspective of those affected by your choices. When you help someone, they benefit in this branch. They don't care about other branches, they care about their actual experience. Your kindness makes their life better. That's enough. That's what morality is for. The multiverse doesn't eliminate the reasons for being moral. It just changes the metaphysical context. Instead of you should do X because Y would otherwise not happen, the reasoning becomes you should do X because Y will happen in this branch, which is the only branch you experience. But there's a deeper issue I want to address. In the multiverse, there are versions of you who do terrible things. There are branches where you commit crimes, betray loved ones, cause immense suffering. These versions are just as real as the version who acts virtuously. How should we think about this? I think the answer is that you're not responsible for other versions of you. Moral responsibility is about your actions, your choices, your intentions. Other versions of you have their own agency, their own deliberation, their own responsibility. Their actions are theirs, not yours. This might seem like a convenient escape. It's not me who did that terrible thing, it's another version of me. But this isn't an escape, it's a recognition of how identity works in the multiverse. In the multiverse, personal identity diverges at each branch point Before a quantum event, there's one you. After the event, there are two yous, two separate individuals with separate experiences, separate choices, separate moral responsibilities. The you who makes a bad choice is not the same individual as the you who makes a good choice. They're separate branches of what was once a single person. You can only be responsible for your own choices in your own branch. And in your branch, the choice is genuinely yours to make. Now let me explore what the multiverse means for the meaning of life. Many people find meaning in making a difference, in having an impact on the world, in contributing something valuable, in leaving things better than they found them. But in the multiverse, every possible impact is made somewhere. Does this undermine the meaning we find in our contributions? I don't think so. Let me explain why. First, the meaning of an action doesn't come from its uniqueness, it comes from its value. Helping someone is meaningful because it alleviates suffering, not because no one else in the multiverse is doing the same thing. The value of the help is intrinsic to the act, not dependent on its cosmic rarity. Think about it this way. If you donate to a charity and learn that millions of others are also donating, does that make your donation less meaningful? Of course not. The good your donation does is real, regardless of what others are doing. The same logic applies to the multiverse. Second, meaning is personal. It's about your life, your relationships, your projects, your growth. The existence of other versions of you living other lives doesn't diminish the meaning of your life any more than the existence of other people diminishes it. Your relationships are real in this branch. Your projects are real in this branch. Your growth is real in this branch. The multiverse is the context, but your life is still your life. Third, there's something beautiful about the multiverse that might actually enhance meaning rather than diminishing it. In the multiverse, every possible good thing happens. Every possible kindness is shown. Every possible beauty is created. Every possible love is experienced. The multiverse isn't just a collection of possibilities, it's a realization of all possibilities. Everything that can be good is good, somewhere. This is a kind of cosmic completeness. The multiverse isn't missing anything. Every potential is actualized. Every story is told. Every life that can be lived is lived. And you're part of this. Your life, your specific life, with all its joys and sorrows, is one note in an infinite symphony. It's not the only note, but it's a real note, contributing its own unique quality to the whole. Some people might find this diminishing. I'm just one among infinitely many. But I think the opposite perspective is also valid. I'm part of something infinite, something that contains everything possible, everything beautiful, everything meaningful. The multiverse is the fullest possible expression of existence. And you're in it, you're experiencing it, you're contributing to it. That seems meaningful to me. Now let me turn to a question that I think is crucial. How should we live, knowing that we exist in infinite worlds? This is not an abstract question. If the multiverse is real, it has implications for how we should think about our choices, our lives, our futures. Let me explore some of these implications. First, consider the question of risk. In ordinary thinking about risk, we weigh the probability of different outcomes and try to maximize expected value. We avoid unnecessary risks because bad outcomes might happen. But in the multiverse, bad outcomes do happen in some branch. When you take a risk, there's a branch where things go badly. Does this mean all risks are equally bad, since every bad outcome is realized somewhere? Not quite. The branches have different weights corresponding to the quantum probabilities. A risk with a 1% chance of disaster creates a low-weight branch with the disaster. A risk with a 50% chance of disaster creates a high-weight branch with the disaster. The total amount of disaster is different, even though disaster happens in both cases. So probability still matters, even in the multiverse. Higher probability means more weight on the corresponding outcome. we should still prefer lower risk options, other things being equal, because they create less total harm across the multiverse. But there's a subtlety. In the multiverse, you will experience every outcome that has non-zero probability. With certainty, some version of you will experience the bad outcome. Does this change how you should think about risk? I think it does a little. In ordinary thinking, we might say, probably nothing bad will happen, and if we're lucky, that's true. In multiverse thinking, something bad definitely will happen in some branch. The question is, what proportion of your future selves will experience it? This might make us take risk more seriously. It's not probably fine. It's definitely fine in some branches, definitely not fine in others. The bad outcome isn't just possible, it's real somewhere. On the other hand, this same logic applies to good outcomes. In the multiverse, good things definitely happen too. When you take a chance on something wonderful, there's definitely a branch where it works out. The good outcome isn't just possible, it's real somewhere. This might make us more willing to take positive risks, to pursue opportunities that might lead to wonderful outcomes, even if they might also lead to disappointment. The wonderful outcome is guaranteed to happen in some branch. Second, consider the question of regret. In ordinary thinking, we regret choices that turned out badly. If only I had done otherwise, things would be better. Regret involves imagining counterfactual scenarios, worlds where we made different choices. In the multiverse, those counterfactual scenarios are real. The world where you made a different choice actually exists in another branch. So in some sense, there's nothing to regret. Every possibility is realized. But I don't think this eliminates regret entirely. Regret is partly about evaluating your past self, recognizing that you made a mistake, that you could have done better. This evaluation is still valid, even if the alternative choice was made by another version of you in another branch. What the multiverse might change is the character of regret. Instead of if only, it becomes I wish I were in that branch. Instead of mourning what could have been, you're acknowledging what is in another part of the multiverse. This might make regret less painful. The good outcome isn't just a fantasy, it's real. Some version of you is living it. You can take comfort in that, even if you're not that version. Third, consider the question of identity and self-continuity. In ordinary thinking, we care about our future selves. We save for retirement, maintain our health, build relationships that will endure. We do these things because we'll be around to enjoy the benefits. In the multiverse, your future selves are multiple. There's not just one person who will inherit the consequences of your choices. There are infinitely many in diverging branches. Does this change how much you should care about the future? Should you care less because no single future self will experience all the consequences? Or should you care more because there are so many future selves to consider? I think the answer is that you should care about all your future selves weighted by their probability, their reality, their connection to you. A high probability future self is more you than a low probability one in some sense. You should weight your concern accordingly. But I also think the multiverse reveals something important about self-interest. In the multiverse, the boundaries of the self are fuzzy. Your future selves branch and diverge, becoming different people with different experiences. At what point are they still you? Maybe the multiverse should make us less focused on narrow self-interest and more focused on general well-being. If your future selves diverge into many different people, then caring about yourself becomes caring about many different people. And if you care about many different people, why stop at your own branches? Why not care about everyone? This might seem like a stretch. But I think the multiverse does challenge our ordinary assumptions about personal identity and self-interest. When the self multiplies infinitely, the concept of selfishness becomes harder to define. Fourth, consider the question of what kind of person to be. In ordinary thinking, we try to be good people, to cultivate virtues, develop character, become the best version of ourselves. We do this partly because good character leads to good outcomes, but also because we value being good for its own sake. In the multiverse, there are versions of you with every possible character. Some versions are saints, others are monsters. Some have cultivated wisdom and compassion. Others have descended into cruelty and folly. Does this undermine the project of self-improvement? If every character is realized somewhere, what's the point of trying to be good? I think the point is the same as it always was. You're not those other versions. You're this version. The kind of person you become is up to you in this branch. The existence of bad versions of you in other branches doesn't excuse you from responsibility for your own character. You're not them, you're you. Your character is yours to shape, your virtues are yours to cultivate, your choices are yours to make. In fact, knowing about the multiverse might intensify the project of self-improvement. In every branch where you make an effort to be better, you succeed. In every branch where you give up, you fail. The multiverse guarantees both outcomes, but which outcome you experience depends on what you do. This is a kind of ultimate freedom. The multiverse gives you every possible future. Your choices determine which future you live. Now let me explore some deeper implications of the multiverse for our understanding of reality. Consider the question of what exists. In ordinary thinking, we distinguish between what's actual and what's merely possible. The actual world is real. Possible worlds are just ways things could have been. In the multiverse, this distinction collapses. Every possible world is actual somewhere. Possibility and actuality are the same thing. There are no mere possibilities, only realities we don't happen to inhabit. This is a profound shift in metaphysics. We're used to thinking that reality is exclusive, that only one world can be real. The multiverse says reality is inclusive, all possible worlds are real. Some philosophers have embraced this view independently of physics. David Lewis famously argued for modal realism, the view that all possible worlds are as real as our own. The multiverse provides physical grounds for a similar conclusion. What does this mean for the concept of truth? In ordinary thinking, a statement is true if it corresponds to the actual world. The cat is on the mat is true if actually the cat is on the mat. In the multiverse, truth becomes indexed to branches. The cat is on the mat is true in some branches and false in others. There's no absolute fact of the matter, only branch relative facts. This might seem to lead to relativism, the view that truth is subjective or arbitrary, but it's not quite that. The truth in each branch is objective. It's determined by the facts in that branch. It's just that different branches have different facts. This is similar to how truth is relative to time. Its reigning is true at some times and false at others. We don't say truth is subjective because of this. We just say truth is time indexed. In the multiverse, truth is branch indexed in the same way. Consider the question of causation. In ordinary thinking, causes produce effects. The cause is a sufficient condition for the effect. Given the cause, the effect must occur. But in the multiverse, causes don't uniquely determine effects. A quantum event might have multiple possible outcomes, each occurring in different branches. The cause is followed by different effects in different branches. Does this mean causation is an illusion? Not exactly. There's still a relationship between causes and effects. The cause is still necessary for the effect, even if it's not sufficient. And within each branch, the sequence of events follows a causal order. What the multiverse suggests is that causation is branching rather than linear. A cause doesn't produce a single effect. It produces a tree of effects spreading out across the multiverse. The causal structure of reality is much more complex than we ordinarily assume. Consider the question of laws of nature. In ordinary thinking, the laws of nature are regularities that govern what happens. All copper conducts electricity is a law because every piece of copper everywhere conducts electricity. In the multiverse, the laws might vary from bubble to bubble. What's a law in our universe might not be a law elsewhere. Does this undermine the concept of laws? I think it refines the concept. The fundamental laws, the laws that apply across the entire multiverse, might be very abstract, specifying only the structure of the branching or the rules for generating different bubbles. The laws we observe in our universe are emergent, specific to our bubble, one instance of a more general pattern. This suggests that our laws are not as fundamental as we thought. They're features of our local environment, not universal truths. But they're still regularities, still useful for prediction, still deserving of the name laws, just not laws of everything. Now let me turn to the question of other minds. In ordinary thinking, we assume that other people have minds, inner experiences, thoughts, feelings. We can't directly observe their minds, but we infer them from behavior, from speech, from the structure of their brains. In the multiverse, there are infinitely many minds, not just other people in our branch, but all the people in all the branches, in all the bubbles, in all the mathematical structures. The amount of consciousness in the multiverse is staggering. And it's not just human minds. Any mathematical structure that supports consciousness is realized somewhere. There might be alien minds, artificial minds, minds we can't even imagine, all real, all experiencing, all part of the multiverse. This might seem overwhelming. How can we care about infinitely many minds? How can our compassion extend to such a vast ensemble? I think we shouldn't try to extend our compassion to every mind in the multiverse. That's not psychologically possible, and it's not morally required. Our compassion is for those we can affect, the beings in our branch, the people in our lives, the suffering we can actually relieve. But we can take a kind of cosmic comfort in the multiverse. Every possible happiness is experienced somewhere. Every possible love is felt. Every possible meaning is found. The multiverse isn't just a collection of suffering, it's a collection of everything, including everything good. And we can feel a kind of cosmic solidarity with all the minds in the multiverse. We're all in this together, this vast, strange, infinite reality. We're all experiencing our small corner of the possible, contributing our note to the infinite symphony. Now let me address some objections to the multiverse. The most common objection is Occam's razor. We should prefer simpler explanations, and the multiverse is absurdly complex. Doesn't positing infinitely many universes violate the principle of parsimony? This objection misunderstands what Occam's razor says. Occam's razor is about theoretical simplicity, the number of assumptions, the elegance of the principles, not about the number of entities the theory posits. The many worlds interpretation of quantum mechanics is actually simpler than alternatives. It takes the Schrödinger equation seriously and doesn't add extra postulates like wave function collapse. The fact that it implies many worlds is a consequence of its simplicity, not a violation of it. Similarly, eternal inflation follows naturally from our best theories of the early universe. We don't add the multiverse by hand, it emerges from the physics. Rejecting it would require adding assumptions to prevent it. And the mathematical universe hypothesis is perhaps the simplest possible theory of everything. All possible mathematical structures exist. That's a very simple principle, even though its implications are vast. Simplicity is about the elegance of the explanation, not the size of what's explained. The multiverse might be infinite, but the theories that predict it are parsimonious. Another objection is that the multiverse is unfalsifiable. We can't test it, so it's not science. This objection has some force, but it's overstated. We've discussed how multiverse theories make predictions about observable features of our universe, the patterns in the cosmic microwave background, the value of the cosmological constant, the behavior of quantum systems. These predictions can be tested. What we can't do is directly observe other branches or other bubbles. But that's true of many things in science. We can't directly observe electrons or quarks or black hole interiors. We infer their existence from indirect evidence. The multiverse is similar. We infer its existence from the success of theories that predict it. The inference is indirect, but it's still scientific. A third objection is that the multiverse makes prediction impossible. If everything happens, what can we predict? This objection confuses everything happens somewhere with everything happens everywhere. In each branch, specific things happen determined by the laws of physics and the initial conditions. We can predict what happens in our branch with the usual methods. What's different is that we can't predict which branch we're in. But this is no different from other forms of indexical uncertainty. We can't predict where we are in the universe. Either we just observe it and go from there. The multiverse makes prediction harder. In some ways, we need to figure out typical branches, likely outcomes, appropriate measures, but it doesn't make prediction impossible. Science continues to work even in an infinite multiverse. Let me now draw some conclusions. We've seen that parallel universes are not science fiction, but the straightforward implication of our best physical theories, the quantum multiverse, the cosmological multiverse, the mathematical multiverse, all of these are serious scientific proposals supported by evidence and accepted by significant numbers of physicists. You exist in infinite worlds. Infinite versions of you are living infinite variations of your life. Every choice you could make, you do make in some branch. Every possibility is actualized somewhere. This is a profound and disorienting picture of reality. It challenges our ordinary assumptions about identity, causation, free will, and meaning. It forces us to rethink what we know and how we live. But I want to end on a note of affirmation. The multiverse, strange as it is, does not undermine the significance of our lives. If anything, it enhances it. In the multiverse, your life is part of something infinite, something that contains everything possible, everything beautiful, everything meaningful. You're not alone in the cosmos. You're one of infinitely many minds, all experiencing, all contributing, all part of the vast tapestry of existence. Your choices matter. They determine which branch you experience, which future you inhabit, which version of yourself you become. The multiverse gives you every possible future. Your choices give you your actual future. Your experiences are real. The joy you feel, the love you share, the meaning you find, these are genuine features of your branch, undiminished by the existence of other branches. Your life is your life, with all its richness and significance. Your relationships are real. The people you love exist in this branch, and your connection to them is genuine. The multiverse is vast, but your corner of it is intimate, personal, meaningful. The multiverse is not a cold, impersonal void. It's the fullest possible expression of existence, containing everything that can be, actualizing every potential, telling every story. And you're part of it. You're living it. You're contributing to it. This is what it means to exist in infinite worlds. Not that you're insignificant, but that you're part of something infinitely significant. Not that nothing matters, but that everything matters somewhere. Not that you're alone, but that you're accompanied by infinitely many versions of yourself, all making their way through their own branches, all living their own lives. The multiverse is real. Parallel universes exist. You exist in infinite worlds. And that's not a diminishment of your existence, it's an expansion of it, an embrace of all possibilities, a recognition that reality is bigger, stranger, and more wonderful than we ever imagined. You exist in infinite worlds, and in this world, your branch, your life, you are real, you are significant, and you are free. That's the truth about parallel universes. That's what the physics tells us. And that's how we should live, knowing that we exist in infinite worlds with wonder, with gratitude, with the courage to choose wisely, and the wisdom to accept what we cannot control. The multiverse awaits. Every possibility is out there, waiting to be experienced. And you, this version of you, in this branch, at this moment, you get to choose what happens next. Choose well. Your infinite selves are watching.